We're going to finish up lesson 2 by looking at examples 3 and 4, which evaluates expressions using the common log and the natural log. So in numbers 9 and 10, we're asked to evaluate each expression, and we have log 10,000. Because this is a logarithm, I find it helpful to set this equal to y. I'm going to write this in exponential form. Now, notice a base to the log is not given. Whenever there is no base given, then this represents the common log, and the base is always 10. So when I write this in exponential form, this is 10 to the y power equal to 10,000. Okay, so I'm trying to figure out how many times I have to multiply 10 to get 10,000. Again, you will have a 4-function calculator. So I'm going to multiply 10 times 10, that's 100, times 10, that's 1,000. A fourth time times 10 makes 10,000. So I know that 10,000 is the same as 10 to the 4th power. So I can rewrite each side as an exponent with the same base, set the powers equal to each other, and y is equal to 4. In problem number 10, I have 10 to the power of log 12. This is an exponent. I'm going to set it equal to x and write it in logarithmic form. So to write this as a log, I'm going to write log. The base of the log is the same as the base of the exponent, which is 10, and we don't have to write base 10. You can, but it's not necessary. So I have log of x is equal to the power log 12. Okay. Since the logs have the same base, I can set the quantities that follow equal to each other, and x equals 12. Go ahead and turn the page. I would like for you to try number 11 and number 12, so pause the video. After you attempt 11 and 12, press play, and I will go through 11 and 12 with you. Okay, problem number 11 is log 14. A logarithm I will set equal to y and put it in exponential form. There is no base, which means it's the common log. So I have 10 to the y power is equal to 14. Now I know 10 to the first power is 10, and 10 to the second power is 100. So there's no way to get 14 using whole numbers. So I think a scientific calculator is going to be required to complete this problem. Now, your calculator only computes log with base 10. Okay, if you have a Texas Instrument, the log button is beneath the blue second key. So if I want to calculate log 14, I'm going to type in log, type in the number 14, and hit equal to. And it is approximately 1.146. Now, the majority of the problems we complete will be computed with a 4-function calculator. We will have a scientific calculator portion as needed. Okay, number 12, again, logarithmic form. So set this equal to y. There is no base, so it's the common log base 10. I have 10 to the y power is equal to negative 11. Now, once again, 10 to the first power is 1. 10 to the second power is 100. Now, if I go negative, 10 to the negative first power is 1/10. So I'm sitting here trying to figure out how I could find y. So if I plug it in my calculator, I'm going to go the log of negative 11. And notice it says domain error. Okay, if you recall, okay, for exponential function, the domains were all real numbers, but the range went from 0 to infinity. Well, for inverse functions, you switch the domain and range. So for a logarithmic function, the domain is 0 to infinity, which means it is not possible to get a value that's negative when you calculate a log. Therefore, there is no solution. Example 4, evaluate each expression. We have the natural log of e to the 4.6 power. Okay, ln is still a logarithm. It's the natural log. So we will set this equal to y. The base of the natural log is base e, that irrational number. So the base of the natural log is e to the power of y, and this needs to equal e to the 4.6 power. Okay, since the base of the exponents are the same, I can set the powers equal to each other, and y equals 4.6. Okay, number 14, the natural log of negative 1.2. Okay, once again, if I set this equal to y, my base is e, so exponential form is e to the y power equals negative 1.2. It is not possible to take a number, e that's positive, to a power and get a negative value in return. Therefore, there is no solution. Problem number 15 is written in exponential form, so I need to change this to a logarithm. So this is equal to x. So if I were to write this as a log, this would be log, the base of the exponent is e, to the x power is equal to natural log of 4. Remember, log base e is the natural log. So this is really the natural log of x is equal to the natural log of 4, because we do not write log base e. When it's the natural log, we write ln. So notice the logs are the same. They're both natural log. So we can set the quantities that follow each log equal, and x is equal to 4. Okay. Last problem, number 16, we have natural log of 7. Again, this is written in logarithmic form, so I'm going to set it equal to y and change it to exponential form. The base of the natural log is e, add to the y power, equal to 7. Okay. Now, if I take e to the first power, I get 2.718. If I take e to the second power, I get 7.389. So once again, I am not going to get a whole number for y. Therefore, a scientific calculator is required to complete this problem. A 4-function calculator cannot calculate this expression. Okay, natural log is typically close to the log. For my calculator, it's right below the log, ln. So I'm going to go second, hit the natural log button, hit 7. Oops, I'm sorry, not second, just hit natural log. So ln will come up. Type in the number 7 and close your parentheses and hit equal to, and you get approximately 1.946. The only time you should use a scientific calculator is if the number is not an integer, a whole number, or the opposite. Okay, if you cannot get an integer answer, then you can use a calculator, but on tests and quizzes, all other answers has to be found using a 4-function calculator.